Today we're starting a new unit dealing with surface area and volume and slicing. And we're going to start with volume and slicing today, going off of the assessment from before spring break. And so first we have a cylinder once again. So this should be review for you guys. And when looking at a cylinder, the base or the bottom of our cylinder is a circle. And we know that the area of a circle is pi times radius squared. And right here is our radius. And so, in order to find the volume of the cylinder, we have to take the base, which is our circle, or pi times our radius squared, and multiply it by the height. So the volume of a cylinder is pi times r squared times h. And now we are just going to apply our formulas. And just like last time, we have our 3 steps. Step 1, write your formula. V equals pi times r squared times h. Step 2 is plug in what you know. V equals pi times r squared. But they give us 10, but remember that's our diameter. So radius is 5 squared times our height of 15. And when we get it all, our step 3, volume equals 235.5 with our label. And remember, it's always cubed. Same over with the other one. We have the 3 steps. Pi times r squared times h. Step 2, plug in what you know. Times r is 2.2 squared times our height of 5. And step 3, gives us volume equals 75.99. And once again, our label, centimeters cubed. This is one of our new shapes, though. And the new shape is a triangular prism. When looking at a triangular prism, notice the end on both sides, it would be, are triangles, hence triangular prism. And then our sides, notice we'd have some more sides here, are rectangles. And something that we can relate is that a triangular prism is 1/2 of a rectangular prism. Because remember, a triangle is a half of a rectangle, so a triangular prism is half of the rectangular prism. And so when finding the volume of a triangular prism, we know the volume for a rectangular prism is length times width times height. And so for a triangular one, it must just be half. Length times width times our height divided by 2 is our volume. And now we're going to apply our formulas. So we're going to find the volume of these 2 triangular prisms. First step is write your formula. Length, width, height divided by 2. And so when looking at it, we have to first take the length and the width from the triangle portion. And then our height can come from the depth. And notice you always want it at the right corner. So we're going to have volume equals 16 times 12 times our height is 10 divided by 2. And when we figure out our volume, we get our volume is 960 cubic centimeters. Same thing with our next shape. Length times width times height divided by 2 is our formula. Step 2, plug in what we know. So we're going to look at our triangular end for our length and width. But no, remember, the height, the triangle has to come from the measurement that makes the right angle. So it's going to be 3 and 8. 3 times 8. And then that depth is 12, so times 12 divided by 2. And when we figure that out, we end up with a volume equals 144 centimeters cubed. Don't forget those labels. Our final new shape is a pyramid. When looking at a pyramid, like the pyramids in Egypt, notice what shape our base is. The base is a rectangle. And a lot of times it's actually going to be a square. But a rectangle is a little more general, encompassing all options. And on the sides, notice what shape those are also. Those are all triangles. And so we can kind of relate a pyramid. A pyramid relates to a cube, as a cone relates to a cylinder. And so we know a cone is a third of a cylinder. And a pyramid has the same relation with a cube. So a pyramid is 1/3 of a cube. And we already know the volume for a cube or a rectangular prism is length times width times height. And all we're going to do is take that and divide it by 3. So the volume is our length times width times our height divided by 3. Unlike the triangular prism, which is divided by 2. And now we have a few example problems. So we need to find the area of our base, the length times our width, and notice this is a square base, and our height. This number actually has no impact. So we're going to put on our formula as step 1, length times width times height divided by 3. Step 2, fill in what we know. 229 times 229 times 145.75 divided by 3. And then step 3 is going to be our final volume. And we get a volume of 47758.6. So 2,547,758.6 meters cubed. And that picture is actually the volume for one of the Great Pyramids in Egypt. And that's why the number is so ginormous, because the volume of the pyramid is very, very large in real life. And now with our other pyramid, our numbers are a little smaller. And notice this also has the square base, but remember that's not always going to be our case. So we're going to write down our formula. Volume equals length times width times height divided by 3. Step 2, put in what we know, 6 times 6 times 8 divided by 3. And step 3 is to write our final answer, which is going to be 96 inches cubed. So volume was definitely some of a review. The cylinder is definitely a review, and the other two shapes are new, but shouldn't be that hard after the last unit. And now we're going to talk about slicing. And slicing is if you would take your shape and cut it down the middle with a knife, what's the shape of that flat portion you just cut? And so I have pictures of the image with a line depicting where you cut, and then pictures next to it show you what the shape would look like. And actually on this slide, these two shapes depicting our slices should actually be flipped. And so if we cut it horizontally, it's this image down here, and notice what shape we get. You get a circle. And this is important information that you're going to need to know. And if you don't quite understand, keep trying, otherwise come talk to me. And now, if we took our cylinder and cut it vertically, which is this image, what are we going to see? Granted, it's tilted, so you could rotate this a little, but notice what shape do you see in here that we just sliced? And if you're seeing what I'm seeing, I would say we see a rectangle. So, sorry that the shapes are in the wrong spots, but know that if you cut a cylinder, depending on the direction you cut, you may either end up with a circle or a rectangle. And it's just wrapping your head around this new idea. It's not too hard, but the more you practice with it, the easier it will become. Next, we have the triangular prism. And so if we cut our prism horizontally in this top image, what shape are we left with? So if we would cut through horizontally, notice what shape we get. we get a triangle. And a way to help you remember this is a triangular prism. You're going to see a triangle somewhere. If we would slice it vertically, what are we going to see? We're going to see the shaded region right here. And it's just the shape as most of the images that we see. It's just a rectangle. It's just you have to wrap your head around what would happen if you cut that image apart. And finally, I'm going to talk about slicing our pyramid. And this picture actually right here is really good. So if we cut our pyramid, is cut horizontally straight through, notice what we see. The pyramid, it's the same shape as whatever its base was. So it is a rectangle. Because all pyramids have a rectangular base. And so if we slice it apart, we would get a rectangle for that slice. And now if we cut our pyramid vertically, there's two different options. For this first cut off to the side, notice what we get. We get something new that we haven't seen yet. We actually get a trapezoid, which is a little unusual, but it's because you're coming where you hit 4 edges, and so that produces the trapezoid. However, if you cut it down the direct middle, this is where it gets interesting. Cutting it down the direct middle only hits on 3 edges, and so that actually gives us a triangle. And so when you slice a pyramid, not cylinder, sorry, when slicing pyramids vertically, you can end up with 2 possible options. You can either get a trapezoid or a triangle, depending on where it's sliced. And once again, the more you practice these, the easier it will become, and the more natural it will become to understand these shapes.